My name is Sethuraman, co-founder of Web3 Compass, and welcome to Build with Stylus. Now, in this series, it's all about helping students and builders dive into Arbitrum using languages you already know and love. Thanks to Arbitrum Stylus, you can now write smart contracts in familiar languages like Rust, C++, Go, and more. That means faster builds, cleaner code, and a much more smoother path to getting your ideas on chain without having to wrestle with solidity. Every episode in the series is going to be hands-on and practical, and we will guide you step by step from getting your environment set up to deploying your first Stylus app on Arbitrum. Now, this whole thing is part of Namaste Arbitrum, an initiative to grow the Arbitrum builder ecosystem here in India through content, education, and real-world projects. So if you're ready to get your hands dirty and ship something real and fun, let's jump in. All right. Now that we have a pretty good understanding of the SDK and what it does and what it cannot do, let's just go ahead and explore it anyway. So to get to the SDK repo, you just have to Google Stylus C SDK and it will take you here. Now, this repository is actually created by Offchain Labs. For those who don't know, Offchain Labs created Arbitrum. So that kind of makes this repository the official one. Like this is the official, Stylus C SDK repository. But as you can see, it's not actively maintained. I mean, the last commit is almost 2 years old. But as I've already told you, this video is not a tutorial on how to create a production grade C smart contract that you can deploy using Stylus. It's more of an exploration of all the possibilities that Stylus brings in. I mean, all of us are familiar with, Solidity contracts or even Rust contracts. But C, while we are exploring this SDK and all its examples, we will get to see what it looks like to create a smart contract using C, right? So to get started with all that, we need to make sure that we have a couple of stuff installed in our computer, right? And to start with, we need something called LLVM. Now, I believe I've given you a very brief introduction to what LLVM is. Simply, it helps you convert C, C++ code into other formats. Like in our case, we need it in the WebAssembly, right? So it helps us with that. It's actually a tool chain. It comes with a lot of stuff, including the Clang compiler and everything. So you just need to install this and, a lot of tools are readily available with LLVM. So to install LLVM, you just open up a terminal, like I'm using my Linux system, and it's a pretty straightforward installation. It's a simple install command. But the thing that you have to keep in mind is that you have to install version 14 of LLVM, right? So just give LLD -14. So yeah, I've already installed it. And once installed, you'll get everything in your system, like all the things that we need to compile and convert our C files. Now, another thing that comes with the LLVM is something called as WASM LD. Now, this is a WebAssembly linker. And what it does is it's actually a component of the LLVM toolchain. And what it does is it is used to link together the WebAssembly object files. Like you need to properly link all the files together for it to work, right? Once we have converted it. So the WASM LD actually helps us with that. But the problem is when you install the, LLVM, the WASM LD usually is installed onto the lib file, like /user/lib file. So we need to move it to our bin folder so that we can execute it everywhere. So again, it's a pretty simple command. Like, this is the command which will just move the WASM LD from lib to bin so that we can execute it everywhere, right? So the system can recognize it and, we can execute it. So once that is installed, you can directly check if everything is properly installed by just doing LD version. Yeah. Now we also need, one more component, which is like the WebAssembly binary toolkit. Now, as the name sounds, the WebAssembly toolkit, it contains a lot of tools that we can use with our WebAssembly files. Now, it also has a repository which you can directly go to, and it contains all the installation, instructions. So just follow this and you can directly install the WebAssembly toolkit, like we need that to help us with a couple of our functionalities, especially with the WebAssembly files. So once you have all that, we are pretty much ready to start tinkering with the SDK. So the next step is to open up a folder and clone this repo, and let's just go through the examples. All right. So the first thing that you have to do in order to get started with the whole SDK exploration is to open up a folder and open a terminal there, git clone. Yeah, you pretty much have the repository in your folder now. Let me just open it using VS Code. Right. So as you can see, it's a pretty simple directory, like the repository. It has examples, like two examples that I mentioned, the ERC20 and the SIPHash, contract, and it also has a few include files, which in JavaScript terms is sort of like the packages, or in other programming languages you might just call them as imports, right? So we'll be using that in a couple of our C files. So we have all that set up, and we have a couple of make files that makes life so much easier. Like all the commands that we need is directly given there. But the thing is, as I mentioned, like the repo is not well maintained. So even if you run these make files, we need to tweak a bit here and there for it to work properly. I mean, I think the best way is to just start tinkering with it, like just try and run the make file and see where the error is, and we'll just correct it as we go along, right? So let me just open a terminal here, and let's just say I'm at the SIPHash file. Like it has a main.c, which, as I mentioned, it takes two arguments and get the hash of it, like you can see it. And this whole SIPHash logic is in the SIPHash.c file, right? So it directly imports this into the main.c, and it does all the hashing, and it gives us the value. So let me just try. And so within the make file, as you can see, it builds the C file, it links it like using the WASM LD, and it kind of formats it using like some of the tools that we installed with the binary toolkit. And then it has some commands to deploy it and check and deploy it. But again, that part is a bit broken at the moment. But yeah, so if we go ahead and give the make command, you can see that there is an error. Like the error is like there is this unknown argument called be static. So it's basically this one. So if you can just remove that. Again, this is what happens when these things update and the repository is not maintained. So now you can see that another one popped up, which is like a WASM strip, which is here. It doesn't require the -o flag. So we'll just remove that. And it's also like the latest version also doesn't require. So this argument, this symbol gets the first file, and this gets the second one. So we also don't need this. We'll just remove that. And again, if we try the make file, you can see that it shows like it can't see the WASM file. Like it is looking for the WASM file, but it can't find it. So what we need to do is we actually need to start compiling our the C file and convert it into WASM. So for that, we need the CLang, which comes with LLVM. So this is the command. Like what it does is it takes all the CLang, it takes all the C files, it outputs it into WASM. The target is WASM32, and it gives a couple of extra flags, right? So just click on this, and yeah, so this is another error because here we are trying to directly import stylus entry.h, which is all the way here. So we need to give the proper path. So what we'll do is we'll just copy the path, go to main.sh. Oh, wait. We'll just paste it here, and yeah, so dot/. Yeah, I guess this pretty much is. So yeah, so that is the error. So let's just try that again. And there you go. You can see that the SIPHash WASM is already here. So now let's just go ahead and run our make command. And yeah, so it is like we have completely, like, everything is linked and everything is proper. So now if the deployment part was not broken, you could actually directly, deploy it to the chain. Like we have the WASM file. So if we put it to the chain, the stylus, will be able to execute this file just like how EVM is executing our Solidity files. Like, once we compile Solidity, it is compiled to a bytecode, and the bytecode goes to the chain and EVM executes it. It's the same thing here, except for bytecode, we are using the WASM, format. So that's how we do it. Like, this is how a typical contract in C looks like. I mean, there will be changes in the syntax and stuff as the repository progresses, but this is the general idea. It's pretty much like your typical program. Like, you have the hash include headers, the user main functions, and within the functions, you have all your variables and types and everything. So the next one, as I've mentioned, is the ERC20. Now, within this file, you have the Solidity implementation of it, as well as the C-based implementation. And as I mentioned, in the C-based implementation, it's like bare metal, like completely, like it does everything from the scratch, like no libraries, no nothing. It has, like, byte manipulation and all those kind of things. But the thing is, it's more like you need to use it in another file to create the ERC20. It's not a file which lets you directly create the ERC20. You need to use this implementation to create the ERC20. So right now we don't have the proper syntax stuff to actually pull it off. Like, they just gave this as an example, like, just to show that this is possible, but we don't have the proper syntax to actually, try and use this to create an ERC20 token. But again, this repository is still in the works. Like, maybe somewhere down the line, we might get a complete working version of the C SDK using which we can do all this. But for now, just remember that, this, what we have done so far is the exploration of the possibilities that we can do with Stylus. And once it progresses and once it reaches, maturity, like the whole project, we will be able to write contracts using languages like C. So yeah, that's it for this video. We discussed quite a lot of things. We discussed a lot of possibilities, but sooner or later, these things will come into play and we will not be bound to Solidity anymore. Like, we could write smart contracts using faster, more performative languages like, C, Go, and of course, like Rust. For Rust, there is an active SDK, but yeah, other languages. So yeah, I hope you guys found this interesting. Now you guys can just go ahead and explore the repository on your own. If you want to, you can even contribute to it and just, let's just try and get this repository up and running faster. All right. So that's it for this episode of Build with Stylus. Keep learning, keep building, and also follow Namaste Arbitrum and Web3 Compass on Twitter for more guides, support, and updates on all things Web3. See you in the next one.